In simulation, this is called domain randomization, and it's important for two things. First of all, so that you can understand, the network can learn that some things that can change, the unimportant things can change. Secondly, is that often we don't really know what the network is focusing on when it learns, and if we're not careful, focus on the wrong thing. It'll focus on the chairs or the lighting or the grass or something like that. And we, by changing the things that should not matter, we can detect whether the network is learning the wrong stuff, and we can focus it in on the stuff that does matter, like the track itself. So it's a good AI training technique. Okay, we'll get into the techniques as we get the racers up, but let's start. So right now there's people just training on the track, but let's start. Let's get them off the track, and let's start with Rainer and Haru, who will be our first two racers. And while we wait for them to get on the track, after the start, just the way this works is, I'm going to say on your mark, get set, go. They are going to, press their auto. They're going to switch their car into auto mode, and it'll then go automatically. The timing starts when they cross the start line. So don't worry if one of them starts sooner than the other. It all works out fine in the timing. And so it may not happen instantaneously, but it is a real race. So I see that I've got Haru,
Chris,
and
here's the deal. I have to start to Rainer, and then you take a couple seconds to run. So Haru, what you can do is, as soon as you see that Rainer is starting, then you can go for it. And that's part number one. So there is Rainer cannot show up, like parking lot nerds cannot show up and then press a button and race at this point. So I have to go, yeah, Haru, that's good. Then you wait there. And then the second part is who gonna, our CAI shouldn't be there. Is it in the meeting already? Is it Ryan?
It's Ryan. You could get off. It's actually Rainer and Haru. So yeah. Rainer is on, but no, sorry, Reiner's not on. So Ryan, there you go. Thank you. So now we're waiting for Rainer.
Yeah, and then so the second part is I can time one of the racers. I can do the inside lane all the time. In this case would be Haru, for example.
I think the timing is going to be automatic this time.
Can you do that from there? It's working, Maxine, so I don't have to worry about it. Okay, cool.
Okay.
All right, so here we go. I'm going to start here, Haru, and then it'll be.
So I shouldn't worry that Reiner's not showing up.
Well, he will show up now, and then as soon as he show up, we're going to start.
All right, let's get started. And while I'm okay, so there we are. Okay, so on your mark, get set, go. So Haru's going to switch into auto mode now. Jack's going to switch Rainer, parking lot nerds. There they go. Okay, so as they're going, first I'm going to tell you a little bit about what's going on. So they are the simulation is running on a server at UC San Diego. The racers are at home, and they are and the code is just running on their own computers. And so what's happening is that the simulator is generating simulated images, sending those images to the racers' computers at home. The racers' computers are then running the neural network as if it were running on the real car, and generating commands. And those commands would be steering and throttle commands. And then the simulator then takes those commands and turns them into the motions of the car that you can see here. So it's essentially exactly the same software that you'd be using in a real car, but this time it is running purely in software and distributed across a server and a client. The rules are, if you hit the cone, it won't stop you. We made this a sort of a transparent cone, but we will take 1 second off your time. That's only for the cone in the middle. If you cross on the wrong side, if you hit or cross one of the cones if you cross on the wrong side of the cones on the outside of the track, that's a disqualification. So let's turn to the racers. Haru, can you tell us a little bit about your car and your training and what's new for this month?
Yeah, sure. Hi, Chris. Good morning. Nothing's changed so far for this month. It's been a final week in UCSD, so I can't really do much. It's the same deal, behavior cloning plus some closed loop speed control on the throttle that allow us to get like a really steady pace, hopefully. And I've turned down the speed control a little bit so that I can at least get a successful run first.
So closed loop, for those who don't know, means that you are sending commands to your throttle, but then you're reading odometry or reading, some encoder, some simulated encoder. Is that right?
Yeah, basically my unit model directly predicts the speed, and I look at the prediction and also my current speed of the car, and I figure out what is a good throttle to put to.
Got it. So you're getting the speed from the simulator. In the real world, of course, you wouldn't be getting that unless you had an encoder. Does your real car have an encoder?
Yeah, exactly. We have our current car have actually a VESC. That's how we control the car. It's actually designed for skateboards. We use it. It's working fine. It's getting encoder values from the brushless sensor motors, and it sends off back to the Just Nano on the USB serial.
Right.
And I can actually read that in Donkey or in our own platform, the Triton Racer.
And that VESC is actually a motor controller that has not just the ability to control the motors, but also gives you feedback, which is great. Reiner,
just a moment, Chris.
Yeah.
We saw also something new that you're showing on when you stream. I'm assuming you're combining the image that you get in real time from the robot. You were showing there what's the first view of the robot. Can you explain that a little bit? Maybe you bring it back and explain what you see there. Did you notice, Chris? He was able to see what the camera was streaming for his control system.
I didn't notice that.
Oh yeah, yeah.
Check that out. Pretty cool.
Yep. I don't know if the Zoom screen is actually big enough on the Twitch, but yeah, basically I just use OBS to. Well, I'm using Triton Racer, so I can actually get a window of the live dash cam feed I'm driving with. And right now it's unfiltered image, and sometimes when we choose, we can actually toggle some filtering. Then you're gonna see some really cool OpenCV image filters going on there. Yeah, right now it's just a live dash cam feed. It's just really cool.
Reiner, we got so caught up in track stuff, I didn't get to you, but I'll tell you what, why don't we move on to the next racers, and I'll have you introduce your car at the next heat, if that's okay.
So we did have some pretty good laps time.
Okay.
So first lap time of Reiner was Jack. You can break the spreadsheet, I think.
I can. It looks like they're updated already.
Yeah, I updated them.
Thank you.
So just Jack, if you want to bring it on the screen.
Yeah, it take a couple of seconds when I click it.
Okay, right. So just go ahead. So we have well, the best lap time is so far 24.9, which was second lap of Haru, and yeah.
That's excellent. Okay, so Haru is now in first place and Reiner is in second place, but it's early days. Next up, we have George and Eric.
That's right. So I will start my donkey car.
All right, very good. Okay, so George is going to be on the inside lane. This is sort of randomly assigned. Very good. Okay.
Let me just re-randomize, and here we go.
Okay, so the cone has been re-randomized, and presumably the chairs have been as well. So racers, are you ready?
Yes.
Both of you?
Sure. It's going to be a bit weird because my car is trained with reinforcement learning and does some weird behavior, but we'll see what happens.
Good. Well, I want to hear all about that. On your mark, get set, go. All right, we have both of them off. Eric, as I guess you're you are Sir Nukal, is that it? What's the name of the car?
I didn't really think of a name yet, but the name that's on screen is just my name backwards. So
very good. So tell me more about reinforcement learning.
Okay, so it's probably not going to work very well here because this is my first time, and also I couldn't get the reward function quite right. What it does right now is, first of all, I'm not using deep learning. I'm using my own tech called Augmaneo, which is like a biologically inspired thing.
Wow.
That uses sparse binary activations everywhere, and it learns completely online without any experience replay or backprop. And it works quite well until there's ping, and until it starts doing, you may have noticed that it waves back and forth. That's because the reward function I'm using is literally just forward throttle. So it always goes full throttle. and then slows down by steering left and right really fast. So that's why it doesn't work. So the reward function simulator is just the absolute value of the velocity as far as I know. But there might be a way to get that, and I just don't know it yet. So
Well, it
right
worked.
now it's
It worked for a while. It was impressive.
it works for a while, and when I run on my computer, it works indefinitely. But it will ram others off the track because of the wavy brakes thing.
Eric, you may want to consider in the future if you think the latency to the server, let's say for UK is, I don't know where you're located, but it's if you're above 150 millisecond, if you give me a Docker container, I can run from the server, and then your latency won't be an impact for your mod. I don't know if it's how sensitive it is for the latency, because what's happening now is that there is an image that show up and then has to be transmitted all the way to your computer where you run in the control system. If that's above 150 milliseconds, start to be hard.
Yeah, I'll have to try that maybe next time.
Yeah,
I'm glad to be able to participate at all.
Yeah,
absolutely. No, we
really
thank you for doing that, and we really appreciate the variety and the new techniques. That's what it's all about. George, you're going really well. Tell us about your technique.
Yeah, my technique is very basic. I just used a standard, let's call it like that, donkey car. But my plans for the future are to add some filters, like half transformation or something like that. And we will see how this works to make it a little bit more independent from, the surrounding.
Now, I noticed that you're not avoiding the cone in the middle. Is that because you didn't train, or is it the randomization is hurting you?
So I trained with one cone, and then I uploaded it to the server, and so we're generating every time a new cone. So this time this is a problem, but yeah, if I had known this before, then I would have trained with a more variety of data sets.
No worries. That's why we introduce new challenges, to make it hard for you.
Yeah.
But you did well. Maxime, how are their times?
Well, he did a 35.4 best lap, which was his latest, and Eric did not finish his first lap. So
no worries.
So yeah.
Okay, so Eric they'll have another chance to come back.
Yeah, sure.
Next, I think we're going to have Ryan all by himself, because I want to put the two jet racers against each other. So Ryan, can you join the server?
I just re-randomized the.
Okay, so the cone and chairs have been randomized again, and we're waiting for Ryan to join the server, and then we'll run him. This is a slight advantage, but he won't get it next time. So next time we'll match him with somebody else. So Ryan, are you ready to go? I'll take that as a
yes.
Very good. On your mark, get set, go. Oops, we seem to have lost you. Jack, is there?
No, not to my end. So everything is running here.
For some reason, the camera is not focused on his car. Why is that?
Yeah, well, he disconnected for some reason.
Oh, he disconnected. Okay, he's back. All right, Ryan, please go when you're ready. And he's off. I don't know who car 2 is, but
and either I don't know if this car chose some random person. Then.
It doesn't matter. As long as Ryan doesn't hit him, we're all good. So Ryan, what's new this month?
What's new this month is I did some training on avoiding the cone, and after that I also tuned it a bit for a bit of speed, since the previous attempts at training a fast model were very stable.
Yeah. Well, you're first of all, you're going very fast, which is really impressive. Secondly, the random cone is in a tough spot this time. It's really right on the corner, and it looks like it pushed you outside of the radius. So I think you got a DNF. this one, but a very promising model. I could see how smoothly and fast you're going. So I think you're going to do very well next time. Maxime, am I correct? Is that a DNF?
Yeah, it's a DNF.
Okay.
Because he ran outside the outer cone. So
no worries, he'll be back. Okay, let's move on to our two Jet Racer cars. Now, while they're so this is going to be this is Andrew and Parth. So if Ryan, you can leave the track, and Andrew and Parth get on the track. So most of the cars you're seeing here are using the Donkey framework, which is it's an end-to-end neural network. It's behavioral cloning, and the way it is that you drive manually around around the track many times, maybe clockwise, counterclockwise. Introduce some variation, upload this match data set of a lot of images and a lot of inputs from your controller to your server. It trains, you end up with a model, and then it runs automatically. It tries to, when it sees the images that it's seen before, it issues a command that it's seen before. That's behavioral cloning. It copies a manual driver. Jet Racer is a framework built by NVIDIA for their JetBot, which is a small robot, and Jet Racer, which is a small but slightly faster robot. And it is using simple supervision. So while we have the racers up, I'll have them explain a little bit. But we have I don't know why they're not quite at the start line. Does it matter?
Yeah. Maybe try to restart.
There you go. Car 2 needs to, whoever car 2 is needs to get off, but they will shortly. Maybe car 2, maybe there was a car 2 that was on. So there you go. Parth is going to come back on, and hopefully.
Yeah, we don't have control over car 2. Chris is some random person. Might post something on our.
No worries. We're in the good
channel, see if we can find who's that person.
We're all good. Okay, racers, are you ready?
Yes.
Parth,
Yep.
Drew. Yep. Okay. On your mark, get set, go.
So this is Jet Racer framework. It's actually running on our Jet Racer or Jetson Nanos right now. We don't have it configured for the desktop version. So we're actually using the Jetson Nano to connect to the server, and we're controlling it via Jupyter notebooks with our computers. But this version, we call it Jet Sim. And that is when Jet Racer is interfacing with the donkey car. And this is actually the first time it's ever been done. Nobody has taken the time to put Jet Racer on the donkey car simulator. So we wanted to get that started. And this has helped us with our, testing and testing out different samples of data and other experiments that we can't do on the track right now with Jet Racer. And like you said, it is made by NVIDIA. It's developed in PyTorch, and it's the amount of images that you can use for this is much less than Donkey Car. So Donkey Car is like around 10 to 20,000 depending on the track length. This only took around in between 300 to 500 images.
And each one of those, I presume, you had to manually tag. As I recall, the process is you move the car, get an image, then click on where the car is supposed to drive. Do it again. So you did that 300 times?
Yes.
Yikes.
And and we do have a process for that. It doesn't work. So the way it's been designed on the Jetson Nano. This framework is pretty much only for Jetson Nano. Like it wasn't really meant to expand into anything else. So we've had to add some extra code, some extra Python code and scripting to just help collect the data, especially from the virtual camera.
So Drew, so the question for Chris still holds, does it mean that you have to stop your robot 300 times?
So what we do is
what
you do is you just drive it into one particular point of the track, anywhere on the track. And then our algorithm, it takes 5 images with just a push of a button. And then you drive to another point of the track. And you just do that. For this data set, I did around 300 images of the yellow line. And then I did 100 images of the cones. But the thing is they're taken 5 times. So it's actually 20 images. I only had to push the button 20 times.
That's
but
awesome.
Yeah, but then to actually map out the path, you do have to click a specific coordinate, and that's how it uses it. You have the XY plane of the image, and then you select the path. Pretty much, you imagine a vector, as in what direction you want it to go for that particular image.
And then for the throttle, how do you feed the throttle into the equation?
That we don't. So the only input it takes is the coordinate that we select and the image itself. And then it uses ResNet 18 pre-trained model to determine like its throttle and steering, which is all made in PyTorch, which we haven't fully exploited yet. That's what we're planning to do in terms of how we can add in throttle. And I did look at other branches of Jet Racer by John Welsh on NVIDIA's GitHub, and they do have throttle. They do have other branches of like throttle input and stuff, but we haven't had time to explore that yet.
So it's pretty cool, Andrew. So number one, Chris, the big difference is run on a very inexpensive computer, right? Like a $90 of I imagine have the 4 gig of RAM. In fact, I know so. And then, so for $90, you can see that the embedded computer is now being used to do something that a desktop would be doing. So Andrew, it seems that you know what you're talking about. Where did you go to school?
UC San Diego.
Yeah, that was a loaded question. So I think they both. It was very exciting, and they obviously are well matched. Why don't we start them again, because they unfortunately ended up in a collision. So Andrew, if you could just disconnect and
Sure.
come back to the start line. We're going to start you guys again because I want to hear from you about what you did differently. And also, guys, did you is your code, which sounds really interesting, is that going to be public? Is that on a GitHub fork?
It is on GitHub. Right now we do have it set to private just because we haven't fully established our main yet. Once that is up and like more robust, we will have a markdown on how to actually install this and try it out and have it public, so that way people can add to the code with their new findings.
And where will you be announcing this?
In Donkey Car Discord, and also with Triton AI, our club.
Terrific. Okay, so for those of you who aren't already on the Donkey Car Discord, sign up, and I guess you'll see that in probably the Virtual Racing League. Or
then maybe what we can do, it's get an introduction for our contact at NVIDIA. You do a little demonstration, because that open a whole other world for people that want to come race with us, Chris, and want to use that framework.
Absolutely.
Especially if they already have a Jet Racer.
Yeah, the moment you guys have this, I will introduce you to the NVIDIA team, and they'll be thrilled to see this, because they've been focused on JetBot, not Jet Racer, and it's really good to see Jet Racer getting some love. Okay, so let's start this one again. Andrew and Parth, are you guys ready to go again?
Yes.
Very good. On your mark, get set, go.
They started.
All right, and they're off. Now, because they started the same time and they're very well matched, I think we may see another collision. That's okay. Oh, wheel to wheel, a little bumping. That's very exciting. Andrew, it looks like, okay, so Andrew, we didn't hear from you last time, I think. I wasn't sure whose voice that was, but
yeah,
Andrew. That was Andrew talking before?
Yeah.
Okay, so Parth, can you tell us about your technique?
Yeah, so mine was similar to Andrew's in terms of how we were able to train, except I did kind of 200 images just on the yellow lane in the middle. And then I did about 60 images of like the edge cases of where it goes onto the track. So if it's on the white line and it's about to go on the grass, just do like a hard turn to like the inside of the track. As well as then I did about 30 of the random cones, but on my local model, I couldn't get the random cones to work. So it only trained on one position of the cone. So hopefully by the next race, I'll be able to get that random cone thing working. So I'll get more data to collect.
Okay, well, this is very encouraging. And Andrew, you now have the track to yourself. So we're going to see what your car can actually do. Maxime, did Parth get one lap in before he crashed?
Yeah, he got one lap. So
terrific. Okay, so Parth, you have time on the board, and Andrew, you are finishing your race.
Yes. So Jet Racer, it has a lot of the values in terms of steering and throttle need to be scaled a lot for the
Mm.
simulator. So I've also worked on the robot side of Jet Racer on the same track in the real life at UCSD, and it's much easier to get a robot actually working just because Jet Racer is designed for that. It's designed for the Jetson Nano on motors.
Yeah.
To get it in the simulator, we've had a lot of things we've had to really fine tune and scale up just because it seems to respond a lot slower to the physics of the simulator.
So do you believe that then the latency, Andrew, I'm imagining you're probably like within 50 to 60 milliseconds to the server. I'm curious what your ping time would be. You think that latency, it could be something that you have to deal with then also in the future, just improve it, especially if you see a cone in when you see the cone, then you have the time that the image come to the Jetson Nano, make a decision, go back as a command, right? That takes some time. Do you think that the latency has some influence of your performance?
Yes, yeah, that is something we're still looking into now. It's just difficult because of our knowledge with the Donkey Car Simulator is not that strong. So we're trying to find the actual like sample rate for the car processing, and then also pushing the information to the simulator and trying to see if there's any kind of latency in that. I did do a ping test, and I'm getting around 30 milliseconds now. And I'm not actually including that in the model. It's just running real time again.
All right, got it.
Okay, well, that concludes the first heat. Right now we have Haru in first place, then Reiner in second place, and Andrew, congratulations, you're in third place. So you did really well in the first one out with Jet Racer. Let's now move to heat 2. So Reiner and Haru, I'm going to have you guys back up again. This is going to be a tough competition. I know you guys can both finish. And so the question is, can you do better than you did last time? Okay, Haru is up. I think, am I right that Reiner's going to come up on automatically?
Yeah,
so
and I have no control. Once you show up, Haru, you can start because it's going to be just a second till he starts.
Okay, on your mark, get set, go. Haru is off. And Reiner is going to be off as well. Okay, so Haru's again, the time starts when they leave the starting line, so don't worry about the distance. But the nice thing about leaving at different times is that you have the track to yourself. Oh no, Haru just runs off. I guess the random cone threw him off. But although Reiner didn't avoid the cone, it didn't throw him off either. So he now gets the track to himself. So we're going to see whether Reiner can do better than he did last time. Reiner's best time is 25.7. Reiner, did you change anything between last time and this time?
No, it's basically the same model. We optimized for the activations on the image. So we set up the camera a bit higher and tilted it more down, so not necessary to crop the image in order to avoid something that is above the horizon. And then we just optimized and used the classical behavioral cloning. So
got it. Maxime, I'm slightly worried that we didn't subtract the seconds for hitting the random cone last time.
Oh, it did.
It did. Okay.
Yeah.
Oh, right. So he's hitting the random cone every time. So he's going to lose 3 seconds.
Chris, just a note. So maybe Reiner can expand a little bit on modifying the hardware. This is the first time we hear someone modifying the hardware on the virtual robot, because usually people just get the full robot that's there and almost don't modify, but it seems that they move the camera up, they change the angle of the camera. Maybe you can expand on that a little bit, Reiner, how we'll be able to do that.
Yes, there is in the myconfig file for configuring the whole setup. You find an entry where you can position the X, Z, and Y coordinate of the camera and the tilting angle. So that's very, very good. There's a good documentation on the Donkey Car side. So if you just adjust that, you're able to well, check for different camera angles, and you can even change the field of view if you want to have, for example, the same camera you're using in the real world with a let's say 209 degrees field of view angle.
And the way you do this is you would get your robot on your local simulator, then you look at the image that the camera was streaming back, and then you make some adjustments. So that's what we did. Similar to what
Yes.
you do if you have a real robot, that you take a look on the Tub 5s and see how those images look like.
Yes, what I basically do is I create a movie with a salient option, and then you can easily see the activations that your model is most prominent working with, and then you see whether which part of the track is easily seen, or which part of the track is not seen at all. And I looked at several of these videos and checked for the, let's say, a more optimal angle and position of the camera, being realistically, so not moving too high.
Yeah.
So
So
something
that's
you can
new.
drive on the real
Yeah.
car.
So that's a new, Chris. We have heard from people doing this before. That's pretty cool.
Absolutely. So Reiner, you did well, but not better than your first heat. Your best time is still 25.7, and your best this time was 25.9. Haru was a DNF, but he still has his points from the heat one. Now, going into the next race, I'm actually going to continue with George and Eric. But afterwards, Ryan, I'm going to have you race one of the Jet Racer guys, and then have the other Jet Racer guy run on his own. So so after George and Eric, I'm going to have Ryan and Andrew, and then Parth will run on his own. So George and Eric, please join. There's George. And there's Eric. On your mark, get set, go.
I'm curious, where are you located, Eric?
I'm in Florida.
And then how did you come
all
up with
this
the
time.
idea?
Oh my. Oh my. Oh, this is
I
this is a
win.
mess. Yeah. Well, let's see. Yeah, you certainly won that. Now the question is, will you oh my goodness.
No.
Okay.
The ping's too much, I think.
Okay, you know what?
It loops indefinitely on my computer.
Yeah. So George, I'm gonna actually bring you, because you got a DNF last time, and you got a DNF this no, sorry, you did not get a DNF last time, George. Yeah, you got George, you got points. So I'm gonna DNF you both this time, but I'll bring you back for heat 3, just so we can move ahead.
Sorry about that.
No worries about that.
Yeah, you'll get another chance, and I may actually pair you up differently, since it seems like you two want to crash.
Yeah, well, especially mine, because of the way it doesn't have brakes, so it just goes left and right a lot.
Exactly. Ryan, I'm going to pair you now with Andrew. So this is going to be a deep racer, a deep racer versus a donkey car.
Nice mix, Chris.
Okay, that is a deep racer on the right. We now have Ryan's going to be joining us, RCAI. He'll be joining us on the left. Okay, on your mark, get set, go. All right, both heading off at the same time. This is again simple supervision versus neural network. Behavioral cloning on the right. Oh, and wow! So simple supervision managed to just bump the neural network, the behavioral cloning off the track, no fault of his own. But now, Andrew, you get the track to yourself. Let's see if you can stay in the lane. You're losing a second for hitting the cone, but that's okay. Okay, that's doing well. So it's going right down the middle of the track. Not a lot of work at finding an optimal racing line. Andrew, did you train for a racing line, or did you decide to go conservative?
So that's something we've been trying out as well, with setting up like apex points for driving, but it's pretty difficult to get. It's the thing is Jet Racer is a very good like line following, road following platform. It's not so it hasn't been so easy to get it to really fine tune the apex points, and that's something we're working on now. But this is as good as we can get it at this point. And I did train it to go around the cones. It will sometimes, but sometimes it just doesn't recognize it. But sometimes depending on where the cone is, you'll see the Jet Racer, it will kind of jerk a little bit right before it sees the cone. So it is responding, it's just not responding correctly.
And I can see your lack of granular throttle control is hurting you on some of these tight curves where you spun out at least once.
Yeah, that's another issue is the throttle itself, because it is from the model. It is a determined value from the model. So we've had to try to override it a few times with setting a higher limit, a lower limit, and then also a scaler. So that way it doesn't speed up so fast.
Yeah.
Because like I said, the physics in the simulator is very different for the Jet Racer. We haven't fully explored all of its capabilities yet.
For sure. Okay, good. So you so your times were let's see, you got pretty much the same. I don't think you're actually just slightly better in the Heat 1. So that's fine. I wouldn't expect it to be different. But Parth, you now get to go on your own. So let's have you join. All right. On your mark, get set, go. So Parth, you were trying to beat 33.7. You just lost a second there for hitting the cone, no problem. So looking very smooth.
Maxine, do you have to manually remove the 1 second way to the cone, or tell me it's automatically also? Then I'm going to be super impressed.
No, it's done automatically.
Yay! Okay. So again, the lack of throttle control means that on some of these tight curves, it tends to go outside and maybe even can lose traction. That's something to be worked on. But it's very smooth within the straightaways. So that looks great.
Yeah, so what I did from the first race was I had the artificial latency of 30 milliseconds because that was like my ping to the server. But on this one, I changed it back to 0. And it seems to be doing a lot better. So yeah, I think as we were talking before, something to do with the ping, figuring out what the most optimal latency, but that's probably at least one of the biggest issues right now compared, in my opinion, for the like Heat 1 versus Heat 2.
For sure.
Yeah, this is exactly have to do, Perf. So when you train locally, then you put that latency there. But then when you're going to be race, you have to remove, because it's a latency on the top of the real world latency. You're basically going to double your latency time. So you should go 0 when you're running on the server.
Oh, that's a good point. Okay.
Yeah, I think that was my issue the first Heat 1.
Okay, I think this is the 3rd lap, or maybe even the 4th. Maxime, is he done?
Yeah, that was the 3rd.
Okay. So let's see how you did.
All right, so
30.1. That's an excellent. Okay, yeah, 30.1. So you now have significantly improved your time. You were at 33.7. Now you're 30.1. Still not good enough to put you in the top 3, but definitely progress. So I think we've done everybody. Now, Eric and Ryan did not get finishes. So I think what I'd like to do, rather than do another heat for everybody, Jack, how do you feel about me letting Eric and Ryan go on their own?
I think it's a good move. Let's go.
Okay, Eric, why don't you go first? We need to get you points on the board.
Sure. I don't know if it will work out, but we'll see.
It's fine. We're going to give you every advantage.
And then while you're going, you can explain to us how you come up with this algorithm, who inspired you to do that, and then maybe
so
you
Ryan,
can talk a little bit more.
Ryan, if you could exit, we want to give Eric the track to himself. Ryan, there you go. Okay. Eric, we are ready when you are.
Sure.
On your mark, get set, go.
Please don't immediately crash. The reinforced learning starts on the right side, so it tries to immediately go to the right.
Oh, no.
Oh,
Well, let's just get you back on the track and let's see what happens. Oh my. Can you restart? Let's give you another shot.
Sure.
We can't move you to the left, I'm afraid.
Yeah.
Actually, maybe we can. Because I think Ryan was on the right track. So let's maybe.
Yeah, it should work nice. This is one of the lesson one for everybody also. So if you always do this alone, you're always going to start on the right lane, and your robot may not know how to start from the left lane. So during your training, you want to consider putting a fake robot in there so it can start on the left lane.
Okay.
Sure.
All right. This should go better.
Hopefully.
On your mark, get set, go. That is better. Okay, here's the toughie. Are you going to make it through the curve? Oh well.
Really? Can I check my ping? I'm just interested what it is so I know how to compensate next time.
Sure.
yeah, sure.
Okay, so that's probably as good as we're going to get, but it's a very impressive technique, and we expect we'll see you again next time. Now we're going to let so that's a DNF. Now we're going to let Ryan go on his own, and Ryan, we know you can finish this track. We've seen you do it many times before, so why don't you get some points on the board? Okay, Ryan, on your mark, get set, go. Oh, lost him. He's going to rejoin.
Yeah, so it's not connected anymore.
Yeah, Ryan's going to join the server again. And Ryan, this is your big opportunity. You have the track to yourself. On your mark, get set, go. And he's off. Okay, Ryan, any changes? I think
Not really, although I made it a bit more stable. Using like the previous data and removing like some of the fast data. Yeah.
Should we try him one more time? We need
Yes,
to get,
please.
yeah.
Let's go,
Okay,
Ryan.
let's restart.
Yeah.
We need you to get some points. Maybe you can crank your throttle down a smidge just to get points on the board.
Yeah, okay, I will do that.
Tell me when you're ready. Okay.
Grace, just for the records, none of the UCSD students have an advantage for running things directly on the server. So they have been running this on their own. In the beginning, remember, we didn't allow anybody to run the code from the server. Now we do, if people provide us a Docker container, but the students present here, they're running the code on their own computer.
Yeah. Oh no, Ryan. So that was close. You almost missed it, but sadly it's unforgiving. What do you say? You want to try one more time, or do you think it's just going to end up the same?
Sure, one more time, yeah.
All right, last one. And then we're going to go straight into the ladder. Oh, now you're in the other lane, so maybe that'll make a difference. Except for car 2 is okay. On your mark, get set, go. Okay, this is your last chance. Let's see whether I can see you crank the throttle down a smidge, so that should be good in terms of consistency. Okay. This was the toughie. You got it through that time? Okay. Well, it looks like you're gonna, oof, I don't want to say anything because I tend to jinx it. It's looking better. Ooh, that was
Yeah,
close.
It's like the demo effect. It's like
Yeah,
when
it
you-
really is. Don't worry about that. the other random, and yes. Okay, you have points. Okay, I think that we can probably just take that first lap. Ryan, if you don't mind, we'll just move straight on because I think that first lap was conservative and you're probably not going to get any faster. So, but we do have points for you. So we're going to, we're now just going to go through the ladder and finish it up. So there we go, 49. Okay, so ladder wise, this is going to take me a second. Jack, why don't you entertain us for a second here while I set up the ladder?
All right, Maxine, what's next race? What's the plan? Do we have a defined track yet? We have a couple candidates. Do we have an idea, for example, how long take it for going for a longer track? If it's even optional, become too long to use.
Well, we have multiple candidates. We have a track created by Jack students. So it's the Thunder Hill track. So it's like the real world track put into the sim. So that should be quite cool. And we have another one that I added previously in the sim, which is the Mini Monaco, which is a flat track with some outside walls. And they are both candidates because they have some outside walls, and we are trying to bring some more lidars for next race. So it will be.
So why do we need the walls for lidar? Why can't not have any wall?
If there is no walls, well, the lidar can't detect any objects and can't navigate through the circuit. So yeah.
And between these two candidates, is there a time, usually an average, what take one lap? Do you have an idea?
I think the Thunder Hill track takes like 1 minute and a half or something like that. And the Mini Monaco takes 40 seconds. So it's two different, I mean, it's longer than what we are used to, but I mean,
so maybe you go try the 40 seconds first before we go to a longer, because
yeah, sure.
In the case of deep learning, people are going to need few laps onto there, who knows, 10, 20, and then they'll take a while. Like if it's 20 and it's like more than a minute, it'll be 20 minutes to train.
Yeah.
Okay. I am ready now for the ladder. The first up, and Jack, if you want to switch to the spreadsheet, go to the tab, the ladder tabs, the fourth tab.
Yeah, so I'm there. So which tab should I go?
Fourth tab, final race ladder. The tabs at the bottom. There you go. That's it. Okay. So first up will be Haru versus Ryan. Second up will be Ryan versus George. Third up will be Andrew versus Parth. And then the winner of each just goes on to the next one. So basically we've got 1, 2, 3, 4, 5, 6 races ahead of us. So Haru and Ryan, you're up. Winner moves on. Okay, Haru's up. Okay, on your mark, get set, go. Okay, again, this is based on time, not on position. So
sometimes I have to control myself here, not spoil the fun, Chris, because I can see the future a few seconds ahead.
You can see, that's right. We have a little bit of lag on Twitch. Oh no, did something dramatic happen?
No, just tell me.
So Ryan's scene is pretty much stalled at this point. Haru wiped out as well. So if Ryan can continue, oh my goodness, if Ryan can make it one lap, he actually wins. Turtle and hare.
Well, that surely is a tricky collocation.
Yeah. Am I right about this? Is Ryan still in the going?
Yeah, he's going.
Oh my goodness. What an upset.
Here we go. I'll tell you something. Boom.
Okay. Haru, I'm so sorry. I'm so sorry, but unfortunately, Maxime, can you keep me honest on this one? Is it true that Haru DNF'd and Ryan completed a lap?
Yeah, that's right.
Okay, Haru, look, you know, it is race day drama, race day randomness. But I know we can see how fast you go, and this is just one of those random things. Ryan moves on. Rainer and George, you're up next. One of the lessons we have, you know, that we're learning here is that it's not just about speed; it's also about consistency. And sometimes the turtle wins by being consistent. Okay, so George is up, and we're now waiting for Rainer. Parking lot nerds.
Oh, that's me. I'm sorry.
Okay. Oh, should I just start George now?
Yeah,
No,
it would
no,
be
no.
great.
Okay, George, on your mark, get set, go. And now, Jack, you can load Rainer in. Okay, and Reiner's going backwards. There he goes.
Taking some swing.
So George is going slowly. Rainer tends to go fast. Looks like he's going to be in
see.
a passing situation here, but passing means danger.
Oh,
George misses. That's great. Oh, boom. Actually speeds him up a little bit, weirdly. Now tries to pass on the inside. That worked. And but George stays on the track. Now Reiner's in the clear. Gets some points on the board. George's only hope here is that Rainer will lap him and wipe out.
Yeah, parking lot nerds, pretty solid model. Pretty nice.
Very solid model, although George, you're doing well.
Yeah, I need to say I only trained with, I think, 50% of the throttle. So we will see how this goes if I train with a higher throttle.
Yeah, it should be inspired by Schumacher.
Okay,
Yeah.
so Reiner's doing very well, but he's coming up on his third lap, and he might lap. The question is he going to? Oh no, is he going to actually wipe out on George before he finishes? So he's coming around the last turn. George is in the distance, and is that the third lap, or is that only the second lap?
Maxine, we have 3 laps.
yeah, we have not yet.
Not yet. Okay, so
we have four Rainer. Yeah.
Okay, so so Rainer has moved on,
and let's just head for George.
Let's just see what would have happened if they had actually. Oh, and he would have passed. Nice move. Okay, so Rainer, you move on. Congrats. Just out of curiosity, what was Rainer's time? 30.9. Okay. Oh, 26.2. I think is that today's track record? No, 25.7. He did faster before. Okay, and now we have the last of the first the first bit of the ladder. That's going to be Andrew and Parth. This is going to be Jet Racer versus Jet Racer. Only one can survive. So Andrew and Parth, please join.
Maybe you guys can race 1 second apart.
Rainer, you need to get off sorry, you need to, let me be nicer about it. You need to just log off.
Jack, please.
Yeah, exactly.
Yeah, Rainer, what are you doing? Rainer, you're going there.
Oh, sorry.
You're just showing off now.
You got me under control, Jack.
Jack, you need to bounce him.
I did.
Okay, so let's Parth, if you could rejoin, you'll be in the correct position. All right, that's one. Andrew is joining as well. On your mark, get set, go. So the times would predict that Andrew would win. Andrew's the favored by only a half a second. So it's very close.
Maxime, the future of you timing this automatically help us a lot. So nice.
Yeah.
Good
Yeah.
job.
Okay,
quite happy
so
because
Parth,
last time.
oh,
Go
sorry.
ahead.
Parth, did you change anything between the last race and this one?
I just changed my throttle gain from 0.7 to 0.75 because I know
Okay.
0.8 makes me spin out. So I don't know if the 0.5 is going to do anything.
Oh my goodness, Andrew wiped out. Parth, if you can finish this, you move on. So you took a chance, you move your throttle up. That meant that you could possibly go faster than him, which you needed to do, but also meant that it was more dangerous. So now we're going to see whether that bet paid off. It looks good so far. I think if you cross the finish line here, you have done more laps than him. Maxine, he's now doing his third lap.
He's now doing his third lap. So
Okay.
Yeah, for everybody that listen to us, so we're starting to value more reliability than just the speed. So you can be really fast, but if you don't complete 3 laps and someone that's slower than you completed the 3 laps, and then that person will advance.
Exactly. But it looks like it's working out well for Parth. So that is it. That is his third lap. Congratulations. Parth moves on. Parth, so now we're going to have Rainer versus Ryan. And then the winner of those two is going to race Parth for the final race. Okay. Rainer versus Ryan. And by the way, actually, there's going to be a final race at the end. It turns out that we can now run more than 2 cars at the same time. So the final races, we're going to have everybody on the track at the same time. It's going to be total chaos. Okay.
Please wait a bit. Just resetting and
No worries.
randomizing. Yeah. We're
Okay.
fine to go now.
All right. I guess we're
So
off.
wait a minute. So do you think you miss Rainer's time? Should I restart?
Oh,
Yeah, why do you restart?
yeah. Let's restart.
Okay.
Just,
Ryan, if you could log off and log back on, we're going to start again. Okay, now Rainer is favored, considerably favored timing wise, but Ryan may have changed something. On your mark, get set, go. Okay. Rainer's off. Ryan is off. Okay, so Rainer's got a good model. We know he can do well. Ryan, did you change anything between the last time, which I think was a DNF, and this time?
I did go and revert to a more stable, more slower model. So I believe that I can complete a lap guaranteed this time. Yeah.
Well, all you need to do right now is hope that Rainer wipes out. Sorry about that noise in the background.
And we have a 43.8 lap time for Ryan.
All right, good. So Parking Lot Nerds is now Rainer is now going to pass Ryan. Let's see if that goes smoothly. Ooh, a wipeout and both dead. However, so they're both out. But I believe that Rainer did finish the required 1 lap. And did it faster. So Rainer moves on. All right, Rainer, you are now going to race Parth. This is going to be a donkey car versus a jet racer.
There's a lot of pressure here.
Okay. Rainer, actually, Jack, I think you need to reset Rainer.
It's coming. It takes a few seconds to start.
Okay, and the rest of you racers, stay on because I'm going to want you all on the track at the same time after this. Demolition Derby. Maxime, have the cones and chairs been randomized?
Yeah.
Okay. Parth is in. Okay, Jack, should I start Parth now and then you bring in Rainer? Oh no, am I misremembering? I can't remember.
Is it Rainer then go, right? Just a moment. Parth, as soon as you see that Rainer gonna show up, you can start, because it take him another second or so to go.
All right, Mark, get set, go. All right, they're both off at exactly the same time. Oh my goodness, this is so. Parth actually took the lead, which is going to be tricky for Rainer. If Parth can continue to block Rainer, then he could win. Oh, this is very unexpected. Although Parth was not as fast a car, his tactics of dominating the track and blocking the track are really paying off here.
Maybe he has a camera facing back, and then he just.
Oh no! Rainer passes on the inside, and clears. So that could be the end. If Rainer can continue consistently through the course, he's going to win. Parth's doing very well.
Parth, like you hit the cone twice, you're gonna lose 2 seconds in there.
Yeah. But nice tactics of blocking the road.
That's some nice racing.
Yeah. Okay, Rainer, you completed your lap, and so I think should we go the 3 laps? Or oh no.
No, yeah, don't. I have to resist here but not tell you guys anything.
Oh no. Okay, so but Rainer's back. He did not go on the wrong side of the cone. It spun him, but he's back and he's going in the right direction. So I think we're still in the race.
Woohoo. Nice.
Oh my goodness. But now he's behind again, which means he's got to pass again. Oh, this is a real race. And he passes. Oh, and he does not pass. And weaving. Oh, what's going to happen on the turn? Oh, and he gets on the inside.
And we have the 3 laps.
And that's 3. What a race. Oh my goodness.
All right. So I'm just going to write down the time.
So that was thrilling.
Now, what we're doing is that the total time for the 3 laps, Maxine?
I'm sorry?
Are you computing the total time for 3 laps?
No, but I can do that.
But it looks like the track record today was 25.7. It was Rainer. So he very consistently, I think he 25.8 was his time on this one. So very consistent. But, in the face of, congestion and, cars weaving in front of him, all sorts of craziness, pulled it out. So Rainer, congratulations. You are our winner today. Rainer, do you have any comments to celebrate your victory?
Well, I dedicate that victory to the whole team of the Parking Lot Nerds, because they supported so much, and it's really a team effort and a team win. So and my thanks go as well to Jack for running our Docker container and
pressing a button,
and to Maxime who assisted a lot and even answering very difficult questions. So. Thank you very much.
Don't worry.
Congratulations. This is virtual champagne being poured over your head. But don't leave because there's one last thing. I need all racers to log into the server, and let's see what happens.
Should I take the race times for everyone, or
no? This is just for fun.
So imagine I could even show up if you want. I have an AI to rob.
Okay. Any other racers? Good. We have 4 racers. Anybody else?
I join soon.
Okay, good. We have 6 racers. This is 7. This is Maxime's joining as well. We've never had so many racers at one time. Okay, I think anybody else joining? Going once? Going twice? Okay, on your mark, get set, go.
Oh, this is going to be chaotic.
It is going to be chaotic. Okay, Haru kicks out first. And, oh my goodness. I can't even.
This is awesome.
So Eric is doing his best to wipe everybody else out. The two jet sim cars are in the front, I think. No. Haru's in the lead. But and then there's a pack at the back who's just trying to kind of hit each other. Maxime, what is your car doing?
Oh, just driving.
Just driving.
It's not an AI made to made for speed, but it's just made for to drive on the track. So
But I'm
just
surprised we still
just
have.
follow the path.
Yeah, we still have. Oh, I think of at least 5 cars are still running.
Yeah. Oh, my car is. I know
Oh, and
it's
Haru
running.
passes the wreck just on the outside. Haru, this could be bragging rights. You could actually win this one. You're passing George on the inside. Very nice pass.
Oh, we have some crash.
And Andrew is off the track. Haru is continuing to weave past all the wrecks. And so there's one car going the wrong direction, and boom, and he's out. Okay, so I think, boy, this is going to be hard to score. Do you think Haru did 3 laps?
I don't know.
I don't know. Let's see. So I don't even know who's. You know what? I'm who's still? So George is still in. Reiner is still going strong.
I'm out.
You're out. So it's just George and Reiner right now. I can't
there
see
somehow.
Oh yeah. Eric is still going
by disconnecting my VPN, and now it works better for some reason.
Oh my goodness. Okay. Well, let's see how. Let's give this one more lap.
Oh.
Eric, congratulations. You're doing much better.
Clearly intentional ram strats here.
Nice. Okay. Well, let's say since Eric is actually doing so well, let's just say that when Eric crosses, I can't quite see where he is, but when Eric crosses the finish line next, we'll call that an end. So Eric is going the correct direction. He's going around the track, weaving, and he crosses the finish line. All right. Congratulations, Eric. Nice end.
Got something done today at least.
Yeah, the technique
Nice,
worked.
Eric. Very nice.
Okay, so thanks to everybody for joining us. We will be doing this again next month. We had about 25 people total on the Twitch stream, which is nice to see. And we expect to return to in-person racing this summer, probably June or July, as you know, as COVID allows. But thank you, Jack, for excellent serving, and Maxime for excellent simming. And thank you, racers, for making an exciting day and putting in the training time. Thanks,
we are
everybody.
getting better, for sure.
All right. We'll see you next month.
Bye, everybody. Stay safe.
Bye.
Yeah.
Thanks, everybody. Bye.
Thank you.
Bye.
Hi, everyone.
Bye.
All right, Jack, if you have a moment after that.
Yeah. Just a moment.
so-
I'm